Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure mathematics one for May-June 2021, and the code is 9709/11. So let's move on to question number 1. Question number 1. The equation of a curve is such that dy dx is 3 over x degree 4 plus 32x cubed. It's given that the curve passes through the points half and 4. Find the equation of the curve. Okay, so to get the equation of the curve is basically to get the y from the dy dx, we need to integrate. Okay, so from here, dy dx equals to 3 over x degree 4. I will move up the x degree 4. It becomes 3x to the power of negative 4 plus 32x cubed. Then my y is the integration of these two terms. Okay, so when you do integration, you need to add 1 to the existing degree. So I'm using this formula. Integrate ax degree n dx. You take out the a and then integrate x degree n. It will be x degree n plus 1 over n plus 1, then plus c. Okay, that means this is going to be 3, then x degree minus 4 plus 1 is minus 3, then over minus 3. Plus 32, x degree 3 becomes x degree 4 over 4, then plus c. So now simplify, it will be negative 1 over x cubed because the x with degree negative 3, so you can move it down. And then 32 over 4 is basically 8, so it will be 8x degree 4 plus c. This is your general equation of the curve. To find the c, we need to replace the point, half and 4. Which means when x equals to half, my y is 4. So 4 equals to negative 1 over half cubed plus 8 times half to the power of 4 plus c. Then from here, you'll be getting 4 equals to minus 8 plus half plus c. Therefore, the c is going to be 23 over 2. So at last, you will be getting y equals to negative 1 over x cubed plus 8x degree 4 plus 23 over 2. So that's the solution of this question. Okay, next question number 2. The sum of the first 20 terms of an arithmetic progression is 405, and the sum of the first 40 terms is 1410. Find the 60th term of the progression. So which means this is arithmetic progression. S20 is 405, S40 is 1410. Now we need to find what is T60. Okay, so for your information, Sn equals to n over 2. As n is the sum of the first n terms, it will be n over 2 times 2a plus n minus 1d. This is the sum of the first n term for arithmetic progression. So now here, I will just replace 405 is n equals to S20, n equals to 20. So 20 over 2, 2a plus n minus 1 becomes 19. Then multiply with d. Okay, then from here, when we simplify, I will get 40.5 equals to 2a plus 19d. That is the first equation. Okay, because the 20 over 2 is basically the 10. This 10, you move it to the left side. Then you'll be getting this equation. Now, for the second equation, I'm going to use S40 equals to 1410. That means 1410 is, now your n is 40, therefore 40 over 2, 2a plus 39d. Okay, then now 40 over 2 is basically 20. So this 20 move down to the left side. For 1410 divided by 20, it will be 70.5. Then for the right side, just rewrite the two terms. That is our second equation. Now, for the first equation, first term on the right side is 2a. Right, for the second equation, first term on the right side is also 2a. So due to that reason, I'm going to use the elimination method to solve these two simultaneous equations, which means I'm going to use second equation minus first equation. So 40.5 minus 70.5, it will be, second equation minus first equation means that 70.5 minus 40.5, I will be getting 30. Then the 2a minus 2a, from that two equations, it will be 0. Then 39d minus 19d, it will be 20d. Therefore, my d is going to be 3 over 2, which is 1.5. Now, we need to get the a now. Okay, so I will substitute it into first equation. So 40.5 equals to 2a plus 19 times 1.5. That means here, I will be getting, 2a equals to this 19 times 1.5 move to the left side. It will be 40.5 minus 19 bracket 1.5. Then you will be getting 12 on the right side. So therefore, my a is 6. So once we have found the a and d, okay, now we need to calculate what is our T60. So the T60 formula is, Tn is a plus n minus 1d. This is the Tn formula, which means the n term. So now T60 equals to a plus n minus 1d, or a plus 59d. Then now replace a by 6 and d by 1.5. Then at last you will be getting 94.5. So that is our 60th term. Okay, 3a. Find the first three terms in the expansion 3 minus 2x to the power 5 in ascending powers of x. So now 3 minus 2x to the power 5. Okay, this one you have to use the binomial expansion, which is a plus b to the power n. It will be a power n plus nc1. Okay, you can write in this form or just write c. Then a power n minus 1 b degree 1 plus nc2 a to the power n minus 2 b squared plus until b degree n. Okay, so, but then when you use this formula, make sure it is a plus. Therefore, here I will have to change. It will be 3 plus negative 2x to the power 5. So it means that your a is 3. Okay, this is your a. And your b is negative 2x. Then from here, I will be getting 3 degree 5. According to the binomial expansion formula, it will be 5c1, 3 degree 4, minus 2x degree 1. Okay, and we need first three terms. So this is our second term. And then the third term, 5c2, 3 degree 3, minus 2 degree 2, plus dot dot dot. Right, so from here, when you simplify the terms, the first one will be 243. The second term, 5c1, this is same as nc1. Okay, so 5c1 times 3 power 4 times negative 2 power 1. It will be negative 810x. And then the third term is going to be plus 1080x squared. So this is our expansion. Okay, now B, hence. Hence means use the previous answer. Find the coefficient for x squared in the expansion. We have done this expansion just now. So what we do is we just rewrite first. But at the same time, due to this squared, we also have to expand the first one. So I will expand the first one using a plus b squared formula. That is the a squared plus 2ab plus b squared, which means when you square the 4, it will be 16. Then 4 times x times 2, it will be 8x. Plus square of x, it will be x squared. Okay, then this degree 5, you can just use the answer from previous part because of the hence. Hence means use the answer from previous part. Then I will be writing these three terms. So it will be 243 minus 810x plus 1080x squared. Okay, now we need to get the coefficient for x squared, which means now I do not need to do the full expansion. So since this is constant, I just need to times with the term with the x squared. Alright, so which means I will be getting 16 times 1080x squared. And then for the next term, since this is x already, it has x already, so it multiplied with negative 810x to get the x squared. So plus 8x times negative 810x. And lastly, okay, since this is x squared, so I multiply with the constant 243. And the rest of the terms I can just ignore them. Then here I will be getting 11043x squared. And now my final answer, the coefficient of x squared, it will be 11043. So that's the solution of this question. Okay, now next question number 4. The graph or diagram shows the parts of the graph of y equals to a tangent x minus b plus c. Given that the b lies between 0 and pi, state the values of a, b, c. So a, b, c are constants. Okay, so now this is a tangent graph. Okay, parts of the tangent x minus a tangent x minus b plus c. Now to get the constants a, b, c, I will refer to my original graph first. Okay, my original graph, if you refer to the tangent graph, here is pi over 2. Okay, so the graph will not touch the pi over 2. So obviously from here, from now, or from the given graph, instead of pi over 2, it has been changed to 3 over 4 pi. That means now you have moved the graph. Okay, so or you can check here. Start with 0, now it start with here. Right, so from here I know that the 3 over 2, the pi over 2, which is what we call as asymptote. Okay, because your graph, this part approaching pi over 2, and the next part is also approaching pi over 2. Alright, so which means now from pi over 2 to 3 over 4 pi, that is how much you have moved. Alright, so move the graph. That means I will just write the one that moved the graph is depends on the b. So my b is basically 3 over 4 pi minus pi over 2. That means this is pi over 4. That is our b. Okay, once you have found the b, then you can check what is the c first. So for your information, when it is c, then you can just use a calculation. Okay, so now let's say I take 1 point, pi over 4. So at this point, this is 1, right? So I will say when x equals to pi over 4, my y equals to 1 based on the point, right? Pi over 4, 1. So then I will substitute back into this equation. So then I will get 1 equals to a tangent x is pi over 4. Then since your b is pi over 4, so you minus pi over 4 and plus c. Okay, so tangent pi over 4 minus pi over 4, this is tangent 0. Tangent 0 is 0. Therefore, obviously the c is 1. Alright, then now once you have found the c and you have found the b, then to get the a, you just take one of the points. So maybe I just take 0. I will just take this point, not 0. I will just take this point. So at this point, the x is 0, the y is minus 1. Okay, so at 0 minus 1. So it means that my y now becomes minus 1 equals to my a is unknown, tangent, my x is 0, then my b is going to be pi over 4, and then the c is plus 1. Okay, then from here, minus 1 equals to a tangent negative pi over 4 plus 1. So tangent negative pi over 4 is minus 1. Right? That means now you will be getting minus 1 is minus a plus 1. Therefore, move the minus a to the left side and move the minus 1 to the right side. So my a is going to be 2. Okay, so I will be getting a is 2, b is pi over 4, and then c is 1. So that is the solution of this question 4. Okay, next question, number 5. The 5th, 6th, and 7th terms of a geometric progression are 8k, negative 12, and 2k respectively. So this is geometric progression. Given k is a negative, find the sum to infinity. So I will get T5 is 8k, T6 is negative 12, or probably, okay, I will just write T5, T6, T7, it will be 8k, negative 12, and 2k. Okay, so for geometric progression, we need to find the common ratio. So the common ratio is R equals to Tn over Tn minus 1. This is the common ratio formula, which means now I will just write minus 12 over 8k equals to 2k over negative 12. This is our common ratio. Then now we need to find the k first, because the S infinity is a over 1 minus r. So now I need to find a and r. So then from here, I will just say the negative 12, this one will be using cross multiplication. So I will get negative 12 times negative 12 equals to 2k times 8k. So left hand side it will be 144. Right hand side will be 16k squared. Therefore, your k squared is 9. Okay, 144 over 16, you will get 9. And your k will be plus minus square root 9. I will be getting plus minus 3. But then since it's given that k is negative, right? So given k is less than 0, therefore our k is negative 3. So with this negative 3, I have to rewrite my T5, T6, and T7. Okay, so now probably I will just write my T6. Okay, so my T6 is negative 12. So then from here, you should understand that the geometric progression, the Tn is ARn minus 1. That is the geometric progression n term. That means from here, I will be getting AR degree 5 equals to negative 12. Alright, then what is my R first? So then my R is going to be negative 12 over 8k. My k is minus 3. Okay, then here is going to be half. Now, my a is unknown. My r already found, which is half, degree 5, that equals to negative 12. That means this is going to be 1 over 32a equals to negative 12. Hence, I can find my a now. So therefore, my a is going to be negative 12 times 32, which is going to be negative 384. So once we have found the r and a, okay, now the question is asking for S infinity, right? So it will be a over 1 minus r. So that means now I will write sum to infinity S infinity is a over 1 minus r, which is half. A is negative 384. divided by 1 minus half. Then at last you will be getting negative 768. So that is the solution of this question. Next question, number 6. The equation of the curve is this. The line is a tangent to the curve. So find the value of k. So whenever you see tangent to the curve means that it will have one intersection point. Or I would say there will be just one root of the simultaneous equation because the tangent line just touches the graph. So then from here, I have to solve the simultaneous equations. Let this be first equation. My straight line is the second equation. So now to solve this, I will just let first equation be second equation. So the left hand side, I will replace it by 3x minus 4. Then right hand side, I will just copy the rest. Okay, so do expansion for the, no need to do expansion, just move all the terms to right side. So then I will be getting 2k minus 3x squared minus kx minus k minus 2, then minus 3x plus 4 equals to 0. So then I will express all these terms in quadratic equation. So here is x, this is also x. Alright, so then since both also minus, then I can factorize the minus. So which means I will be getting 2k minus 3 x squared, then minus x bracket. Once you factorize the minus x, you will get k, and then minus 3x, you will be getting plus 3. Okay, and then here, the last one will be negative k minus 2. Now, I will combine these two constants, but then since there is a minus outside, means that when I factorize minus from plus 4, I will be getting minus 4. Okay, and now I simplify it first. 2k minus 3 times x squared minus k plus 3x minus k minus 2 minus 4 will be minus 6. Okay, so now since it's mentioned the straight line is a tangent, that means we know that it will be just one root for the simultaneous equation. On other words, I would say the discriminant will be 0. Okay, so before I write out the discriminant, I will just write out the coefficients first. Coefficient for x squared will be 2k minus 3. And then for the x, it will be b, which is negative of k plus 3. And then the constants will be negative of k minus 6, which is this. Ax squared plus bx plus c equals to 0. Right, so now we start with b squared minus 4ac equals to 0 because straight line is a tangent. It's only one root. So now replace the b, it will be negative k plus 3. Then you have to square this value. Minus 4a, a is 2k minus 3. Then the c is going to be negative of k minus 6. Then equals to 0. Okay, then from here, since the first one is squared, that means we have to do expansion. But minus squared is positive. So I just need to do expansion for the k plus 3 squared. That means you'll be getting k squared plus 6k plus 9. Okay, and then followed by the expansion of these two terms, then I will be getting minus 8k plus 12. Alright, so probably I will just leave the minus outside first, then it will be easier for me because I need to expand with the another bracket. So, or probably, okay, I just direct simplify here. You see here minus, I do expand this first, this minus, and then another minus here. So minus minus is a plus, right? So I will be getting plus, and then followed by this 4 multiplied to the terms before I multiply to k minus 6. So which means here is going to be minus. Okay, so then equals to 0. Then now I will do expansion for the bracket. So first three terms just rewrite. So now you do expansion. Then you will be getting 8k squared. 8k times minus 6, it will be minus 48k. Minus 12 times k, it will be minus 12k. Minus 12 times minus 6, it will be plus 72. Okay, so now simplify. K squared plus 8k squared, it will be 9k squared. And then followed by 6k minus 12k minus 48k. So it will be minus 54k. And then the constant, 9 plus 72, it will be 81. Alright, so before I solve this quadratic equation, I notice that the whole equation can be divided by 9. So I divide by 9 first. It will be k squared minus 6k plus 9 equals to 0. And then this can be factorized. It will be k minus 3 squared equals to 0. You must only get the repeated factor because of tangent. Okay, only one root is allowed here. Hence, my k is going to be 3. So this is the solution for this question. Okay, next question 7a. Prove the identity 1 minus 2 sine squared theta over 1 minus sine squared theta is 1 minus tangent squared theta. So I will start with the left hand side because it looks complicated. Okay, so first of all, I will start from the right hand side because the tangent, right, you can change the tangent to sine over cos. So I will start from right hand side. It will be 1 minus sine squared theta over cos squared theta. Then now you get the same denominator. So it will be over cos squared theta. So the first one, 1, becomes cos squared theta over cos squared theta. That's why numerator is cos squared theta. Then minus sine squared theta. Okay, so now we need to prove this. So obviously we cannot accept the cos squared theta. Therefore, we use the identity, which is sine squared theta plus cos squared theta is 1. So now cos squared theta, it will be 1 minus sine squared. Okay, just use this identity to change everything to sine squared theta or sine theta. Then I will be getting 1 minus sine squared theta minus another sine squared theta over the cos squared theta is 1 minus sine squared theta. So from here, I will be getting 1 minus 2 sine squared theta over 1 minus sine squared theta. So we have proven the identity. Okay, next question, B. Hence, solve the equation. So we have proven this just now equals to 2 tangent degree 4 theta for the theta defined from 0 and 180 degrees inclusive. So it means that now the left hand side, I will just change to 1 minus tangent squared theta. And then right side, rewrite. Then now I will rearrange them. So it will be 2 tangent degree 4 theta. Move these terms all the left side to the right side. It will be plus tangent squared theta minus 1 equals to 0. And now I let u equals to tangent squared theta. Then I will be getting 2u squared plus u minus 1 equals to 0. So this is a quadratic equation. Now, this quadratic equation can be factorized into 2 linear factors, which are 2u minus 1 times u plus 1 equals to 0. So then from here, 2u minus 1 equals to 0, which means your u is half, or u plus 1 equals to 0, then your u is negative 1. Okay, done. Then you don't forget, your u is tangent squared theta. So now change back. Alright, so tangent squared theta is half, or tangent squared theta is negative 1. So we know that whatever squared of the value, it cannot be negative. That means this one no solution. Okay, so now tangent square theta is half, which means your tangent theta is plus minus 1 over square root 2. Now, by looking at the theta interval, it is from 0 to 180 degrees, which means you have to consider the angle in first two quadrants, because it will be tangent negative plus and minus for the first two quadrants. So now you have to get the answer, the basic angle from calculator first. So your theta is inverse tangent 1 over square root 2. Then you will be getting 35.3. Okay, this is the basic angle when you take inverse tangent 1 over square root 2. And then the other one is also 35.3, but then our angle is in the first quadrant and also second quadrant. So now the first quadrant, it will be 35.3, and the second quadrant is going to be 180 minus 35.3. Okay, then you will be getting 35.3 degrees and 144.7 degrees. So that's the solution of your question. Okay, next question, number 8. So this is the diagram. Now the diagram shows a symmetrical metal plate. The plate is made by removing two identical pieces from the circular disc with center C. Alright, now the boundary of the plate consists of two arcs, PS and QR. So this is a PS and QR. These two are the arcs of the original circle, and the two semicircles PQ and RS as diameter. So this is a diameter. Okay, now the radius of circle with center C is 4. So since the PS and QR are the arcs, that means this when I draw, okay, okay, something like this. So alright, so now radius of the circle with center C is 4. That means here is going to be 4. This is 4. Okay, then the PQ and RS is 4. So if PQ and RS is 4, since this is the diameter, that means here is 2. Up to here is 2. This is another 2. Right? So this is the diagram. Okay, now show the angle PCS is 2 over 3 pi. So PCS is over here. Now what we need to do here is, alright, I will refer to this triangle, right angle triangle. Okay, since PQ is a diameter, that means this is going to be 90 degrees. Now I will define first. I let the midpoints of PQ be M. Let's say this is M. Okay, so in my working, I will let M be the midpoint of PQ, which means now I will be drawing this diagram. Here is P, this is M, and this is O. Not OC. Okay, we know that here is 2 units. This is 4, 2 cm, 4 cm. And then now you need to show PCS. So if you want to show PCS, I need to find what is this first. Okay, so therefore I find PCM. So let M be the midpoint of PQ, and then PCM angle PCM be theta. So from this right angle triangle, I know that I'm given the PM, which is the opposite side, which is 2, and the PS is the PC is the hypotenuse. So you have opposite and hypotenuse, which means it's the sine. So I will write sine theta is 2/4. Therefore, theta is inverse sine half, which is pi/6. So I know that this is pi/6. Okay, but then if you realize that the PMC and this S and this bottom rectangle triangle, they are same triangle because radius is the same, right? Then this side also 2, here is also 2, which means this is also pi/6. Then now I can find my angle PCS by using pi minus pi/6 minus pi/6. So then my angle PCS, it will be pi minus 2 of pi/6. Therefore, it is pi minus pi/3, and at last you will be getting 2/3 pi. So that is our angle of PCS. Okay, now B, find the exact perimeter of the plate. So we know that perimeter of the plate means that you need to find, okay, this one I erase. Then from here, you need to find the arc length of PS and QR, but both of them are same, okay, same length. And then I need to find this semicircle length, right? Then from here, for the arc length of a sector, just for information, let's say this is R, then the S is going to be theta R. So from here, I will write perimeter equals to, okay, when you look at here, just now we have found this angle is 2 pi/3. Right? So the R is 4. So obviously this whole sector PSC, right? This PSC, this arc length here is going to be theta R, which means 4 times 2/3 pi. But then since this QR is same as the PS, okay, therefore I will just times 2. So I will write it is 2 times 4 bracket 2/3 pi plus with the semicircle, okay, circumference of the semicircle. So I can treat this as the sector as well, right? Since these two, the upper and the lower semicircle are the same, that means I will just times 2 to this value. So this value, the angle is pi, okay, then the radius is 2, so it will be 2 pi for the arc length. So I will write 2 times 2 pi. Therefore, this is going to be, the first one is 16/3 pi, and then the next one is going to be 4 pi. So at last, it will be 28/3 pi. So that is the perimeter of the plate. Okay, next, show that the area of the plate is this value. Okay, so now area of the plate is the same concept as just now. Okay, so I will have to find the area of this sector. So it is double. Okay, so when I draw, right, when I draw properly, actually, it's like this. Okay, so my diagram is not very accurate. Then after that, you have to get area. Area means that this part. So when you want to get this, right, it will be triangle, area of the triangle, PCQ, minus area of this semicircle. Alright, so now for your information, if let's say this is the area, this is a, what is that called, the sector. So your area is half r squared theta. Okay, so now I will write down the concept first. Area equals to 2 of area of sector PCS plus, so area of sector PCS means that you have found all this. Okay, so basically the sector supposed to be like this. Okay, then now you have to find the area of triangle. So basically you want to find this. So you have to find area of triangle PCQ minus area of the semicircle. Alright, that will be the total area. So then I will write over here, it will be plus area, or it will be 2 times, right? So everything times 2. So 2 times area of triangle PCQ minus the semicircle. Alright, so here will be 2. Now, using this formula, half r is 4. So 4 squared theta is 2 over 3 pi just now. Plus 2 area of triangle. Okay, how to get area of triangle? So we know that here is 2. Oh no, here is 4. Total is 4. And then this is 4 as well. Okay, just now we have solved. Look at here. The angle is still here. This is pi over 6. So if here is pi over 6, that means here is going to be pi over 6 as well. So pi over 6 plus pi over 6 end up with pi over 3. Okay, so we have a formula. If let's say you are given a triangle, this is a theta, this is A, this is B. Wait, no, okay, no need to use that. I will just use half r square. Okay, here is 4. This is, if here is 4, this is also 4. Okay, I will use this as my B because you already have the data. So which means now the area of the triangle is half AB sine theta. So I'm going to use these 2 sides. Okay, so 4, 4, then the angle is pi over 3. So here is going to be half 4, 4 sine pi over 3 minus the area of the semicircle is basically pi r squared. Alright, so for the circle, okay, remember this is a semicircle. Okay, the sector is supposed to be here. Okay, so here when you refer to this, it's supposed to be like this. Right, my diagram is not very accurate. It should be just touches the, something like that. Okay, so then from here, when you look at the semicircle over here, the r is 2. Okay, our semicircle is half pi r squared. That is a semicircle because semicircle, because the area of the circle is pi r squared, so now half because of semicircle. So this is half pi r squared. Your r is 2. Okay, so from here, the first one, when you simplify, the 2 and half cancel off, then you will be getting 16. 4 squared times 2 is 16 times 2, which is 32. Then over 3 pi. Okay, plus. Now, the next one is if you multiply the half and 2, when you simplify, it will be cancelled off. So sine pi over 3 is basically square root 3 over 2. So 4 times 4 is 16, then square root 3 over 2. Then minus 4 pi. Then from here, 32 over 3 pi minus 4 pi, you will be getting 20 over 3 pi. Then the 16 over 2, you can simplify it into 8. So at last, you'll be getting plus 8 square root 3. Then this is your area. Okay, so done for this question. Now next question is question 9. Functions f and g are defined as follows. Given fx and gx, state the range of f. So now we know that the minimum point, right, minimum point of f is with coordinates, let this be 2, and then this is the y coordinate. Since your x is greater or equals to 2, which means this is your 2, negative 4. Which means all your other y must be greater than minus 4, but you can accept exactly minus 4 because your x including exactly 2. Therefore, from here, the range of f, it will be fx at least minus 4. So that's the solution for 9a. Now b, find the f inverse. So just let it be y first for the fx. So y equals to fx. Then y equals to x minus 2 squared minus 4. And now get the x as a subject, which means now x minus 2 squared, it will be y plus 4. So x minus 2 will be plus minus square root of y plus 4. Then your x is, move the minus 2 to right side because 2. Then instead of plus minus, just leave it first. We need to just choose one of them. But then how to choose? It depends on your range. So your range is greater or equal to minus 4. Therefore, we choose plus. Alright, otherwise you will get a negative value for your y values. Why do we use this? Because we know that domain f inverse is range f. Range f inverse is domain f. Okay, so this whole term is actually the range f inverse. That means it depends on domain f. Okay, so I shouldn't refer to the range, sorry. So it should be domain f. So look at the domain f is at least 2. So because of at least 2, for this whole expression, therefore you have to choose plus, cannot choose minus. So that's the explanation. That means now you'll be getting f inverse equals to 2 plus square root of x plus 4. So that is your f inverse. Okay, part C. Given a equals to negative 5 over 3, solve the equation fx equals to gx. So now I have to rewrite my gx first by replacing the a. So now my gx is negative 5 over 3x plus 2. And then my fx is x minus 2 squared minus 4. Okay, since fx equals to gx, that means x minus 2 squared minus 4 equals to negative 5 over 3x plus 2. Okay, so first of all, to solve this means that you need to find x. So the minus 4 will be moved to the right side. So when I move the minus 4 to right side, it's going to be x minus 2 squared equals to negative 5 over 3x plus 6. Okay, then from here I will do expansion for the left hand side using quadratic formula. Therefore, this is going to be x squared minus 4x plus 4. Then right side, you can just rewrite. And then now to solve this quadratic equation, I don't want the fraction. Therefore, I times the whole equation by 3. Then you will be getting 3x squared minus 12x plus 12 equals to minus 5x plus 18. And move all the terms to the left hand side. Then I will be getting 3x squared minus 12x plus 12 plus 5x minus 18 equals to 0. And now simplify this, all these terms, you will be getting 3x squared minus 12x plus 5x, it will be minus 7x. Then 12 minus 18, it will be minus 6 equals to 0. And then from here, when I factorize this quadratic formula, quadratic equation, I will be getting 3x plus 2 times x minus 3 equals to 0. Therefore, 3x plus 2 equals to 0, or x minus 3 equals to 0. Hence, my x will be negative 2 over 3, or x equals to 3. Okay, but then can we accept both values? Let's check. So, for the fx to be defined, your x must be at least 2. Okay, so that means now, since you are solving fx equals to gx, means that these two values must satisfy the both x and fx and gx. So now you just write given x is at least 2. That means our solution is x equals to 3. Okay, that's the final answer of this question. Okay, now D, given instead GGF inverse 12 is 62. Find the possible values of A. So, GGF inverse 12 equals to 62. I find what is my F inverse 12 first, because this is a composite function. So F inverse 12, you refer to the parts B. F inverse is 2 plus square root x plus 4. Okay, so 2 plus square root x plus 4. That means this is going to be 2 plus square root 16. Then I will get 2 plus 4, which is 6. Then now, GGF inverse 12 is same as GG6. Okay, because the F inverse is 6. So now, GG6, I need to get what is my G6. So my Gx, go back to the original function, Gx is Ax plus 2. So now I'm going to replace my x by 6. So it will be 6a plus 2. Then again, g of 6a plus 2, which means now this x will be replaced by 6a plus 2. So this is going to be a times 6a plus 2, then plus another 2. Okay, and this is going to be 6a squared plus 2a plus 2. And now given, it is 62. Which means 6a squared plus 2a plus 2 is 62. Then from here, I will be getting 6a squared plus 2a. This 62, you move to the left side and total up, it will be negative 60 equals to 0. Then obviously, this equation can be divided by 2. So once I have divided by 2, it will be 3a squared plus a minus 30 equals to 0. Then now I will factorize this quadratic equation into two linear factors. Then you'll be getting a minus 3 and 3a plus 10. Therefore, a minus 3 equals to 0, or 3a plus 10 equals to 0. Hence, my a is going to be 3, or a equals to negative 10 over 3. Okay, so these are the two A values, because in the question is mentioned possible values of A. So you should get more than one A then. Okay, now next question, number 10. The equation of a circle is this. Okay, this is a equation of circle. A, find the x-coordinates of the points A and B where the circle intersects the x-axis. So when intersects the x-axis means that the y equals to 0. So I will let y equals to 0. Therefore, x squared, this is 0. So minus 4x, then minus 77 equals to 0. Then now, this must have two linear factors. Then you'll be getting x minus 11 and x plus 7. Therefore, my x minus 11 equals to 0, or x plus 7 equals to 0. So you will either get x equals to 11 or negative 7. So these are the two x values of the points A and B. Okay, now part B. Find the points of intersection of the tangents to the circle as A and B. So just now we found A and B, the x coordinates, right? So now to get the tangents, we need to get dy dx, which is the gradient of tangent. This is a gradient of tangent. After that, we substitute into the straight line equation. So now what we need to do here is we have to rewrite the equation of the circle. X squared plus y squared minus 4x plus 6y minus 77 equals to 0. Okay, now to get the dy dx, this is the implicit differentiation. So we have to differentiate. So when you differentiate 2x, x squared, it will be 2x. In differentiate y squared, when you differentiate, right, differentiate a function of y with respect to x, it will be differentiating the function of y with respect to y first, then you times dy over dx. So this is the implicit differentiation. So now when I differentiate y squared with respect to y, it will be 2y. Then now we need to times with dy dx. But then for the next term, when you differentiate minus 4x, it will be just minus 4. So the fourth term, 6y becomes 6 dy over dx. 77 becomes 0. Then at last, it will be 0. So now, to find the gradients of tangent at both points A and B, so I will just write at A. Let's say, for example, the A is with coordinates minus 7, 0. I choose the x equals to minus 7. Okay, so now I will direct replace the x and y to get the dy dx, which means I will be getting 2 times minus 7 plus 2 times 0 dy dx minus 4 plus 6 dy dx equals to 0. So I will be getting negative 14. Okay, second and third term will be 0. Second term will be 0. Okay, then third term you get minus 4. Then next term, just copy. Then from here I will get 6 dy dx equals to 18. Therefore my dy dx is 18 over 6, which is 3. So this is our gradient of tangent at point A. So now I can just write equation of tangent at A. So use the formula y minus y1 equals to mx minus x1. So it becomes y minus 0 is 3 bracket x minus minus 7. So this is y equals to 3x. So here is plus 21. First equation. Because we need to find intersection point between the two tangents. So now I need to find the equation of tangent, or I need to find the gradients of tangents at points B. So just repeat all these steps. Okay, so at B, just now we have found the x coordinate. So another x is 11. So I let it be the points B. Points B with coordinates 11, 0. Then now I will just substitute into this equation. Okay, so 2 times 11 plus 2 times 0 dy over dx minus 4 plus 6 dy dx equals to 0. Then now, here you will get 22, second term is 0, so minus 4 plus 6 dy dx equals to 0, which means now here I will get 18 plus 6 dy dx equals to 0. In other words, your dy dx is minus 3. Okay, so now I can find equation of tangent at B with coordinates 11, 0, and together with this m. So I will get y minus y1 equals to m bracket x minus x1. Therefore, this is y equals to negative 3x plus 33. This is my second equation. So to find the intersection points, I have to solve first and second equations. So now I will just I will use elimination method because both left hand side equals to y. So I will write second minus first, or first minus second, because the second has a negative x. So first equation minus second equation. So when you minus, you see the y minus y will be 0. So first of all, on the right side, in the first equation is 3x. And then you minus 3x becomes 6x. Third term, it will be 21. Then minus 33. So it will be negative 12. So from here, 6x is 12. Hence your x is 2. Okay. Then now from one of the equations, more probably I use the first equation, it will be easier. It will be y equals to 3x plus 21. So 6 plus 21, it will be 27. Therefore, I found the points of intersection. That will be having the coordinates of 2 and 27. So that is my intersection point. Okay, next question, number 11. The equation of the curve is this. Is given. A, find the equation of normal to the curve at the point 4, 4, giving your answer in y equals to mx plus c. So equation of normal, we need gradient of normal. Gradient of normal is same as negative 1 over gradient of tangent. Right? And then gradient of tangent is basically dy dx. So which means now we need to differentiate. So before I differentiate, I will change the square root to degree half first. So it will be 2 times 3x plus 4 with degree half, then minus x. This is my y. So now, my dy dx, when you differentiate, you always move down the degree, and this is going to be a power rule. Okay, or I would say this is just mx plus b, then degree n. So it will be n mx plus b degree n minus 1, and differentiate mx plus b, it will be m. So now there is a 2 outside there, so I will just remain. Now to differentiate degree half of 3x plus 4, I will just apply this formula, bring down the half, rewrite the function, and the degree you minus 1. So half minus 1 is minus half. Then after that, differentiate 3x plus 4, it will be a 3. Close bracket, and differentiate minus x is minus 1. So then from here, I will simplify first. The half and 2 cancel. Then you will be getting 3 over square root, because of the negative degree, 3x plus 4, then minus 1. So now you need to find equation of normal at this 4, at the points 4, which means now I need to find the gradient at this point. So my dy dx equals to 3 over square root of 3 times 4 plus 4 minus 1. This is going to be 3 over 3 times 4 is 12. 12 minus 4 is 16. So square root 16 minus 1. This is 3 over 4 minus 1, which is negative 1 over 4. So then gradient of normal is negative 1 over dy over dx, which means this is negative 1 over negative 1 over 4. Then I will be getting 4. Alright, so now with this gradient and also the points, I can form the equation of the normal. It will be y minus y1 equals to m bracket x minus x1. So at last it will be y minus 4 equals to the m is 4, then x minus 4. So you will get y minus 4 equals to 4x minus 16. Hence your y equals to 4x minus 12. So that is your equation of the normal. Now B, find the coordinates of the stationary point. Stationary points means dy dx equals to 0. Just now we have found the dy dx. So dy dx just now was 3 over square root of 3x plus 4 minus 1. And now you let this be 0 because of the stationary point. So 3 over square root of 3x plus 4 minus 1 equals to 0. So the minus 1 will be moved to right side. So I will get 3 over square root of 3x plus 4 equals to 1. Okay, so the square root will move out. So I'll get 3 equals to square root of 3x plus 4. And now to eliminate the square root, you need to square both sides. So which means the left hand side will be 9, right hand side will be 3x plus 4. So now my 3x equals to 5. You move the you move the 4 to the left side, which means now my x is going to be 5 over 3. So that means the stationary point occurs at x equals to 5 over 3. And then now I need to find what is my y coordinate. So my y is 2 square root 3x plus 4 minus x. This is from the question, which is here. Right, so now just need to replace the x value by 5 over 3. Then my y is 2 square root 3 bracket 5 over 3 plus 4. Then minus 5 over 3. Then from here, it will be 2 square root of 3 times 5 over 3 is basically just 5. So 5 plus 4 is 9. Then you will get 6 minus 5 over 3. At last, this is 13 over 3. Okay, so which means we have found the stationary point. So stationary point with coordinates 5 over 3 and 13. Sorry. So the stationary points with coordinates 5 over 3 and 13 over 3. So that's the solution of this question. Okay, now see, determine the nature of the stationary points. Nature means you need to decide by referring to the second derivative. whether it's maximum or minimum point. So now I will rewrite my dy dx. Okay, so this is your dy dx. I will move up the square root, so it becomes degree negative half. So my dy dx is 3 times 3x plus 4 to degree negative half and then minus 1. So 3x plus 4 to degree of negative half and then minus 1. Now, I need to get second derivative. So keep the 3, bring down the negative half, rewrite the function. Then now the degree, instead of minus half, you minus 1. You minus another 1. So it means that minus half minus 1 is negative 3 over 2. Then now differentiate 3x plus 4, it will be a 3. So minus 1 becomes 0. Then from here, right, you simplify, it will be negative 9 over 2. Then 3x plus 4 to the power of 3 over 2. Once I've moved down the 3x plus 4. And then now you have found the stationary points in the previous part, x equals to 5 over 3. So now I will replace the x by 5 over 3. Then my d squared y over dx squared will be negative 9 over 2 times 3 bracket 5 over 3 plus 4. And then the whole degree is 3 over 2. Okay, then from here, when you simplify, the 3 and 1/3 cancel off. So at last, you will be getting negative 9 over 54, which is less than 0. So when it is less than 0, which means this is a maximum point. Okay, so you will just write here 5 over 3 and then 13 over 3 is a maximum point. Okay, so that's the nature of the stationary point. Now D, find the exact area of the region bounded by the curve x-axis, the lines x equals to 0 and x equals to 4. So now, for the area, okay, you are not given the graph, but it doesn't matter as long as all the values are given. So you need to integrate this y with respect to x because you are given the x values from 0 to 4. So I will write integrate 0 to 4. The y is 2. Square root you change to degree half. So 3x plus 4 to the power of half minus x dx. This is your y. So when you integrate, let's say you need to integrate this. Right, we will use ax plus b to the power of n plus 1 over n plus 1, and then when you differentiate ax plus b is a, then plus c, provided the n is not minus 1. Then from here, I will just take out the 2, and now for my integration of 3x plus 4 to the power of half, I will get 3x plus 4 to the power of half plus 1, which is 3 over 2. Then divided by 3 over 2, differentiate 3x plus 4 is 3. Then integrate x is x squared over 2. And put another square bracket from 0 to 4. So probably the first one I don't use square brackets, I just use a normal bracket. Okay, now when I simplify, the first one will be 4 over 9 because here 3 times 3 is 9. 9 over 2, you move up the 9 over 2 becomes 2 over 9. So with by multiplying it by with 2, it will be 4 over 9. So I'll get 4 over 9. I rewrite this first, 3x plus 4 to the power of 3 over 2. Then minus x squared over 2. Then limits 0 to 4. Then now, when you replace the x by 4, I will get 4 over 9. Then 3 times 4 plus 4 to the power 3 over 2 minus 4 squared over 2 minus, when the x is replaced by 0, so 4 over 9 bracket 4 to the power 3 over 2, then minus 0. So here you will get 4 over 9, this is 16 to the power 3 over 2, minus, this is 16 over 2, so 8, then minus, here is going to be 4 over 9 times 4 to the power 3 over 2. Then at last you will be getting 256 over 9 minus 8 minus 32 over 9. So lastly, the area is going to be 152 over 9. So this is the exact area. Okay, so this is the end of the question and also the end of the video. Thanks for watching. Please subscribe to the channel and continue support this channel. And also stay tuned for more upcoming videos. Thank you. Bye.